So let's now find an equation of a curve that passes through the point 1, 1 and whose slope at every point x, y is given by y squared over x cubed. So this means we want to find a curve that has the property that its derivative at any point is y squared over x cubed. And so there's a separable differential equation that we need to solve, and the solution will be the equation of this curve. So putting everything in terms of y on one side of the equation and everything in terms of x on the other side, we can now anti-differentiate. We get negative 1 over y is equal to 1 over x squared with a negative 1 over 2, and our arbitrary constant of integration plus c. So here's an implicit relationship between x and y. We can now solve explicitly for y in terms of x. First thing I'll do is multiply both sides by negative 1. And now we can take the reciprocal of both sides. And multiplying top and bottom by 2x squared gets us that the curve has to have this form. And now this is just the general solution to the differential equation. We still need one additional piece of information. We want to find the curve that passes through the point 1, 1. So if y of 1 is to be equal to 1, then that means we can get an equation for what c has to satisfy. And so this means that 1 minus 2c is equal to 2, or 2c is equal to negative 1, or c is negative 1/2. And so therefore our solution is y is equal to 2x squared, 1, 2 times c, well c is negative 1/2, so 2 times c is negative 1, so that turns into a plus 1 as the coefficient of x squared. And so there's the equation of the curve that has the property that the derivative is y squared over x cubed at every point xy, and it passes through the point 1, 1. So the point 1, 1 is somewhere over here. And so our solution looks something like this. So there's a rough sketch of the graph, and here's the equation of the resulting curve.